Let's test these things out. So I'm having a cubic here, which I print. Let's print it again. Or let's, I don't know, auto something. Let's do this. Yeah, and I'm just changing it. So let's say px dot. This doesn't make any sense. I'm actually changing the thing here. So this is not operator star. This is equal operator. No, not sorry. Like that. To stay a cubic. Okay, so we want to have a friend cubic. Operator star. Yeah, just a cubic on one side, I guess. It's the left hand side, and then some expression. You need both, really. It seems more logical to put a vector up front. Left hand side. Cubic const reference right hand side. So the cubic result, return result. And I just make a copy of the right hand side then. And then we do right hand side multiply with the left hand side. Bleep. Can do the same for divide. And while I'm at it, you can do the same for addition. Yeah. And then vice versa. It's just a lot of work, but just can't deny that we just should do this. So now put the cubic first anyway. Then the left hand side, right hand side. And then of course you have to make a copy of the left hand side, which you don't multiply with the right hand side. And then we're going to do the same thing for division. And addition. And subtraction. Okay, so here I could now do px. I don't know. Let's try anything, something. Let's add just random thing, skill x. Then I print it again. Assigning to value type a const expression pointer from incompatible type. Yeah, I have to take the pointer of that thing again. There are many other things we run into there. No viable overloaded star. Result. Oh no. The right is the result is a copy, yeah. The left hand side, so this should be the result. Now we have to change it in 8 places or something. Result, left hand side is result. The right hand side is result. The left hand side is result. Right hand side is results. The left hand side is results. Assigning to value type. Okay, it's the same thing again. So I need to take the pointer of the result of this. Valid operands. Anyone looking at it is deciding never ever going to learn C++. But hey, it's compiled. So now I run this. Yeah, it works. Well, at least the plus works. So I define a polynomial which mysteriously doesn't print a plus here. Yeah, I changed the printing thing as well, so let's fix that first. Printing does not print a plus in front of the x to the power 3. Why not? I'm not sure. I think this should go here. Okay, so we have this. That is a monic polynomial because the coefficient here is 1. And I add scale x randomly. Some symbol. And then the result is this. Yay. Let's try the other ones as well. For example, instead of adding something, we can subtract it, of course. That shouldn't be. It should not fail. Like, I mean, come on. Okay, then I subtracted it. And then we can try the multiplication. So yep, this is multiplied by scale x, and this one's multiplied by scale x, and that one's, and that one. And then, yeah, division. I mean, do we really have to check that? Not the same thing, but then with to the power of -1. Each and every one of them. And then, of course, I could also have done auto px2 is px times scale x. It should compile. Wait a minute. Let's print the result. Okay, so that works like the same way, except now the derivative was not changed, so the px was not changed. Yep, I'm totally happy with this. So this now works. I can multiply and divide and add and subtract stuff to inform cubics. So what I have here is that I want to scale stuff with this vector. Pretty sure I'm doing that. So that would be this. And you see that the x double prime to the power 3 gets a vector in front of it. Which looks like the third power of this thing, x to the power 3, which is correct, I think, yeah. If you scale something with e to the power x, then every x here gets multiplied by that. But I want to keep it a monocle, so now we have to divide to the third power of ex. This polynomial. So let's change this thing to itself divided by the third power of ex. I do this transform, but I want it to be divided by ex to the power 3. Let's see what the result is of that. So that's that worked, and now it is just x double prime to the power 3. This coefficient was removed. It doesn't look very simple, does it? I'd expected this thing to become way more simpler as well. Not to mention the rest. Yeah, my simplification is kind of lacking here. It's not really doing all what I had hoped. Let's just dump this in Octave, which is not possible because of the double prime. Let's rename that. So I'm currently having an XPP, which then I call double prime. Just call it PP. Let's call this one P. One thing, if we do that scale, I mean, let's put it this way, I have a polynomial now where the inflection point is at x is 0. Meaning that, the inflection point is the point where the second derivative is 0. So here I'm just saying what it is, and then we evaluate it, and then it does simplify to what it is, namely 0, so I can print it in. And then we do a scale with this and divide it by the third power of that, which then gives me another polynomial, of which I then calculate just the first derivative actually. So this is the first derivative of that polynomial, but then evaluate the first derivative at 1, and that should be 0. So this should be 0. And I'm really disappointed that it doesn't print 0, but so simps, you have the symbols C1 and C2. That's it. So simplify this whole thing is 0. So it could have done that immediately. Like it is simply a 0. So that is, yeah. I don't know why it's failing to see that. I mean, this is even the same. Bring this out of the parentheses to front fit whatever, then you get okay, without the 3 then, so we get C1 minus 1/3 C2 squared divided by this. Yeah. Which is minus 1/3 of that. So that if you calculate this minus 3 and then plus 3 is 0. But my program is not seeing it. Let's see, what else can we do here? Oh yeah, I want to simplify this one. Let's just simplify the whole thing. Because I have the feeling that it should be way, way, way simpler. Oh god, now you have to do the power 3 like that. Yeah. seems how many other symbols do we have now? C2, C3, C1. C3 does not exist. And XPP. To add it, so I just need C0 and XPP. And then I'd say, what is this thing called? Just assign it like that. To the power 3. There's no square. Oh, that what is the only thing then? XPP undefined. CPP. XPP. Simplify. No, that's hardly simpler. Actually, it should have been. If you divide this by that, then it becomes a nice harmonical thing again. It should have been, and here as well. See? Totally simple. Let's do an expand of this. Let's say PS is that. That's the polynomial simplified. And then I do PS expanded. Expand PS. Yeah, that's definitely not what I expected. No, I should have done collect or something. Let's do collect. That's or not. Dude. Why is it not just printing XPP to the power 3 minus 3 times XPP? Minus, okay, something more complex, but not more complex than we have now. Okay, that should, I don't know, let's do something like the constant term. Can I do capital C as a different thing? Is substitute and then this thing where we substitute XPP with 0. That's just a constant thing, and then we can get the next one. Let's say I subtract this now. So do PSE minus C0. and then divide it by XPP. Really? You have to tell it to simplify stuff, otherwise. And then we get something simple. Right. So yeah, let's do display and simplify C0. That's as good as it gets, I guess. C squared, C2 squared minus 3C1. That is kind of embedded in this as well. Multiplied by a C2. And then there's this factor 2. So you just something left over, which you could combine with that one. But a substitution with this wouldn't be too bad. Okay, anyway, the coefficient, let's see, I'm just gonna do quit, forget everything. The coefficient of this XP here should be minus 3. So this whole bloody thing is actually minus 3. That's really sad that it doesn't figure that out by itself. I still have to run octave again because I have to check it. Simps. And there's a C1 and a C2 in it again. C1 and C2. Simplify. Minus 3. Yep. Okay, I want to try to only use transform. So you begin with hello, Siddhant Chapade. Let's begin with C3, why not? And then I can do a transform here. It would actually be easier if just could assign. Wait, maybe I can that. I can do that. So just divide by the coefficient of x to the power 3. So that the same thing as getting a monocle, but still having the C3 in it. Then. So we could do px simply becomes. No, I want to. Yeah, I want to use transform. Right. So px becomes px dot transform. And then the first one is the x scale, so that you don't scale x, right? No, it's just the y scale. And then this must be 1 divided by C3. I guess I can just do 1 divided by C3 here. And we don't shift anything. Let's write here out what we are doing. Divide x by C3. Keep forgetting this. I have to transform takes possibly a new symbol, but yeah, I keep changing symbols. So every time I do a transform, we have of course a different x by substitution. But yeah, I mean, keep doing that. We'll just keep calling it x. In fact, it is still x, because if you divide a whole polynomial by something, the polynomial is set to 0. The roots don't change. That means that the x doesn't change. What is this? Cubic cannot be assigned because the copy assigned operator implicitly deleted because the field x is of a reference type. Well, then maybe I should change that to a pointer. X underscore. Pointer here, store a pointer everywhere. Use it as a non-pointer, however. And then here we print x. Cubic transform. I'm not even using x here. That was it. No, not octave. Are we doing any break anytime soon? What do you mean? I just started the stream. What are you talking about, Sid? You had some doubts regarding the coding world. What's a big world there, out there. I wonder what kind of doubts you have about the coding world. Tell me. Anyway, this turned out to be working, right? We have everything divided by C3. And then end up with 1 here, of course, because C3 divided by C3, that is 1. And I did it with the transform, okay. First derivative, second derivative, so that is just proof that the inflection point is at this, but it no longer is, which is why this failed, I think. A third failed, right? It's no longer 0. Sufficient constant is 0 failed, yep. Well, that is because we reintroduce C3, because actually this must be 3 times C3. That is the inflection point. We should get past that one. Yup, so using this, the second derivative at the inflection point is 0, which is why it is called the inflection point in the first place. Well, that's not true, of course. Inflection point is just, you know, that point over there. But the second derivative is 0 at that point, so yeah. This must be the inflection point. And then what's next? The t of transformed. To do the same thing as here, just print what we are doing in terms of transform. That would be the pt. Okay, so move the inflection point to x equals 0. T out. Notice shift IX. No. Yeah, well, shift what? I'm gonna call it a polynomial. So shift PX. IX to the left. It's basically what we want. Move the dot even there. And now we can at least just print this again. And then the transform, I'm going to do that the same way. I'm just reassigning it to px, I think. Same way as here. That is. So I'm going to just print px, and the rest won't work anymore. I can calculate a new derivative. Am I even interested in the derivative? Maybe I am. I want to verify that this is 0, but it doesn't work. Maybe I should use some numbering though. Every time I transform it, a new number. So this is a px, I don't know, let's call this px0 then. And then here you can call this px1. Then px0 transformed. And this is the derivative of px1. Second derivative of px1. So another transform, which we then print. And then I can do the derivative of px again, but now with the 2. And then to drop the prime. Just the derivative of px. Well, actually, sorry, the prime here means derivative, so print that, and this is then px2 instead of prime. This is probably also not correct. I have to figure out what. I mean, now I have a C3. Again, but okay, suppose we get a right formula here and we can print it, and then we can prove that it is the extreme, because if we fill that in the derivative, then we get dpx to evaluate that, which should be 0. So maybe I should name this one also a 2. Like, it's after a transform, you get a kind of a new coordinate system, which is now numbered by a 2. So you can only combine variables that are numbered the same, which means that my ix also belongs to coordinate system number 1, even though I just give it, because I don't have a solve. So I use Octave to find this, or actually you can do it out from my head. Simply solving the second derivative, setting the second derivative to 0. And then we do another transform. So this becomes now px 3 is px2 transform. And here I divided, what is, wait a minute. That would be the same as y scale. So I think I might as well add it here. X to the power 3. That remains x. Twice my other transform. Still xp here. So use an x as well. And then this should already be done, and then this can be called simply px after the transform, which is now px3. And then we can calculate the derivative, because apparently that is required. And then we can say the derivative is now that, and then I want to show what is that evaluated at 1, where this is the px3. No, probably forgetting something, but if it compiles, oh, I would be happy. Of course it doesn't compile. Auto missing. EX was renamed to EX2. And it compiles. Now what do we have? Oh, it's still highlighting. But that's because that's the wrong one. So this should be the x coordinate of one of the extremes. And it changed from this formula because I brought the C3 back. So I have to figure out again what is the solution of setting this equation to equal to 0 now. And only Octave knows that. So we do symbols. The symbols that we have is C1 and C3 and C2 and X. And let's say my derivative P is that thing, or I have to use this, and that's the square. Okay. I really have no idea what's talking about floating points. These are integers, moron. What is dangerous about integers? Complete nonsense. Anyway, it still works. So we have now the derivative of my polynomial here. Yeah, because there was this thing. And I want to set that one to 0 and then solve for x. That gives me the coordinates. So I do some kind of equation which is now equal to the derivative set to 0. And then solve that equation. Finding x. But I didn't do anything. Solution. I don't know, print one of the solutions. Display solution number 1. So this should be equal to what I had if C3 equals 1. And then I believe it. I believe it anyway, actually. But let's copy this, create, go back to the program. Square root. Well, the other one is a plus. Okay, so let's remove this one. So we have the square root of minus C1 divided by 3. And then minus minus is a plus. C2 squared divided by 3, which is divided by 9. So yeah. And now we have to add the C3 back by doing times C3 here. And then the whole thing outside of the square root must be divided by C3. What a mess. Let's clean it up a little bit. So I don't like the minus sign much. So let's do C2 squared minus that. There's a minus 3 here. Go back, go back. Nope, remove the minus here. Add the minus here. And toggle this minus. And then just let's subtract C1 times C3 here. So I can get rid of this. I probably should leave it like this. I'm not really interested. No, actually, I should not leave it like this. I want a positive one. I mean, the inflection point was moved to the x equals 0, so the local extremes are left and right of that with equal values except for a minus, so it's plus or minus something. And I want to have the plus value here. So if I write it as a square root of something, then it's always plus, except of course when C3 is negative. So to get rid of that, we just bring the C3 inside the square root. Problem solved. So I want this whole thing divided by C3 squared, then yeah, so this divided by C3 squared, that can be removed, and then this thing divided by C3 squared, and now we are back at something where we just divided by C3. Of course, I should have done that immediately. This makes so much sense. I don't need these parentheses though. Square root of something. What is? Yeah, okay. And this, okay. And then we have that square divided by 3 minus that. Okay. So really necessary, because I thought that it feels like it makes more sense to multiply this thing by 3. To multiply this by 3 and that by 3. So what will this thing by 3? then I have to divide it by 9. So let's divide this by 3 here, and then we have to multiply this by 3, which means that this is gone, and this is 3 times that, and then divide by 9 inside the square root, might as well divide it outside the square root. So you have to do everything yourself. It's unbelievable. And then these can be removed as well. It gets simpler and simpler. No, not safe. Pling, and still it doesn't work. Exponent failed. Okay, what did I do wrong? Oh, yeah, it is C++, so there must always be parentheses around the exclusive OR, which I abuse as an exponentiation. I think what it'd be because of the precedence. I think what it did was the 2 minus 3 first, or something. Or maybe, I don't know, probably. Okay, so adding parentheses around this should solve this problem, I hope. And it did. Okay, so now we have, this is what I just figured out. Proof, if you fill that in this formula, you get 0. Ta-da! So it was done correctly. Yep, this is the positive root of this first derivative, aka this is the one of the x-coordinate of one of the local extremes. The minima even, because we divided the whole thing already by C3, so that is a monomial polynomial, which goes to plus infinity for x goes to infinity, which means that the minimum is on the right. So for the positive x gives us the minimum. And then we have this one. Did I forget to shift to the left? And here we don't say anything. Transform, here's a transform, yeah. What am I doing here? I'm doing two things at once. Scale the x-axis by a factor of ex, so that the extrema will be at plus and minus 1. And divide the polynomial by ex to the power 3 to keep it a monomial. Monic. Or what is it? Monic is it? It's continuously gambling. Now I know for sure that it was wrong. To keep it monic. A monic polynomial. Or something like that. Check, check. Yep, it's a monic polynomial because the coefficient here is 1. And we already know that this thing should have been incredibly much simpler. My symbolic library is so failing me here. Sucks. It sucks. So yeah, I believe that this is actually -3. Hey, Post Bunny. You know, the thing is, I tried to store everything in a canonical way. That is, any expression is always stored in the same way. And then I thought, well, it automatically means that if an expression is 0, it's going to store it like 0. Because there's only one way to store 0, right? Apparently not. Okay, I can begin with extracting this coefficient, I think. I think it's an expression. Really? Yeah. Yeah. I thought it was way longer than it was before, but it is actually this long. No, okay, so you have 9 times C1 divided by C3 times blah blah blah, just the same thing. Now, I think there is a trick that I could do. I think that when I want this to be equal to -3, yeah, or I can prove that by applying the same operation to two variables, where one variable is this one and the other variable is -3, and then in the end get them to become the same thing. No, don't know how to do that yet, but so begin with okay, this should be equal to -3. So I'm going to set, I'm going to call this thing, no, I can't, damn it. I can only, this is a cons reference and stuff, so they're all stored in a database. The only thing you can do is create new expressions. So you can't say I make a variable and then I make changes to that variable. It just doesn't work. But, well, I can work with pointers. So what you can do is say auto, and this is then my pointer. We call that the left hand side. And we make that point to C0. And then I want to have an auto right hand side, which points to, I mean, you can use pointers because, you know, they are just like Git. It's just stored in the database and never changes. So 3. Well, actually -3. So I just say -3 here. Or I could create a -3 first, but actually I have to do that anyway. We need an expression here, so yeah. Can I create a -3? Actually, well, let's just create it right here, so that it is a constant. Realize, and then I think just -3. That should work. Yep. Do. No, let's make sure that we're doing something that makes sense. So the right hand side is equal to the right hand side. Post Bunny, I have a question for you. Oh, should I go eat dinner today? I have 23 minutes left before the shop closes, so I should like get up now and get dinner. Run. Okay, thank you. Thank you for taking care of the inner Carlo. Well, people, you hear it. The Post Bunny is in charge. I'm going to get dinner. I'll be back later, okay?